Let's begin by understanding what evaporation actually is. Evaporation is a natural process where a liquid, most commonly water, changes into a gas or vapor. This transformation happens at the surface of the liquid and doesn't require the liquid to reach its boiling point. It's a crucial part of the water cycle and plays a significant role in our daily lives, from drying clothes to forming clouds in the sky. In this video, we'll break down each step of the evaporation process and see why it matters. Truly grasp evaporation, we need to look at water on a molecular level. Water is made up of tiny molecules that are constantly moving. These molecules are held together by bonds, but they're not static. They vibrate, rotate, and move around. The energy they have determines how fast they move and how likely they are to escape from the surface into the air. This constant motion is the key to understanding how evaporation begins. Heat is a form of energy, and it plays a vital role in evaporation. When water is heated, its molecules gain more energy and start moving even faster. This increased movement makes it easier for some molecules to break free from the surface. Even without visible heat, like on a cool day, some molecules still have enough energy to escape, which is why evaporation can happen at any temperature. Evaporation happens only at the surface of a liquid. The molecules at the very top have a chance to break away and become vapor if they have enough energy. Molecules deeper inside the liquid are surrounded by others and can't escape as easily. That's why the surface area of a liquid affects how quickly it evaporates. The more surface exposed, the faster the process. Temperature is one of the biggest factors influencing evaporation. Higher temperatures mean more energy for the molecules, so more of them can escape into the air. That's why puddles dry up faster on a hot day compared to a cold one. However, evaporation still happens at lower temperatures, just at a slower rate. Wind or moving air can speed up evaporation. When water molecules escape into the air, they can linger near the surface. If the air is still, these molecules might return to the liquid. But if there's wind, it sweeps the vapor away, making room for more molecules to escape. That's why laundry dries faster on a breezy day. Humidity refers to the amount of water vapor already present in the air. When the air is humid, it's already holding a lot of water vapor, so fewer water molecules can escape from the liquid. On dry days, the air can absorb more vapor, so evaporation happens more quickly. This is why sweat evaporates slower in humid weather. Evaporation is all around us, even if we don't always notice it. When you spill water on the floor, it eventually disappears as it evaporates. Wet clothes hung outside dry as the water turns into vapor. Even when you sweat, your body cools down as the sweat evaporates from your skin. These everyday examples show how important evaporation is in our lives. Nature relies heavily on evaporation. Lakes, rivers, and oceans constantly lose water to the atmosphere through this process. This water vapor eventually forms clouds, which later return as rain. Without evaporation, the water cycle would be incomplete and life on Earth would be very different. It's easy to confuse evaporation with boiling, but they're not the same. Boiling happens throughout the entire liquid at a specific temperature, while evaporation only occurs at the surface and can happen at any temperature. Understanding this difference helps explain why water can disappear from a puddle even on a cool day. Evaporation is a key part of the water cycle, which keeps water moving around our planet. Water evaporates from oceans, lakes, and rivers, rises into the atmosphere, and eventually falls back to Earth as precipitation. This endless cycle supports all forms of life and shapes our environment. Evaporation has a cooling effect. When water molecules escape from a surface, they take heat energy with them, leaving the surface cooler. That's why sweating cools your body and why a wet towel feels cold as it dries. This principle is used in many cooling technologies. Several factors influence how quickly evaporation happens. These include temperature, surface area, air movement, and humidity. By changing any of these, you can speed up or slow down the process. For example, spreading water out in a thin layer helps it evaporate faster than if it's in a deep puddle. Industries use evaporation in many ways. For example, salt is harvested by evaporating seawater in large, shallow ponds. Cooling towers and power plants rely on evaporation to remove excess heat. Even in food processing, evaporation is used to concentrate flavors or remove water from products. Plants also rely on evaporation, a process called transpiration. Water travels from the roots to the leaves where it evaporates into the air. This helps plants stay cool and draws more water and nutrients up from the soil. Transpiration is vital for plant health and for maintaining moisture in the environment. Evaporation plays a big role in shaping weather patterns. As water vapor rises, it cools and condenses to form clouds. These clouds can lead to rain, storms, or even snow depending on conditions. Without evaporation, our weather would be much less dynamic and predictable. Many products we use every day rely on evaporation. Perfumes and air fresheners work by evaporating scented liquids into the air. Paint dries as the solvent evaporates. Even some medicines are delivered through evaporation, like inhalers. This process is more common in our lives than we might think. Understanding evaporation helps us conserve water. Covering pools, using mulch in gardens, and storing water in closed containers all reduce evaporation. These simple steps can save significant amounts of water, especially in dry regions where every drop counts. Evaporation is easy to observe in science experiments. You can place a small amount of water in a dish and watch it disappear over time. By changing variables like temperature or airflow, you can see how the rate of evaporation changes. These simple experiments help us understand the science behind the process. On a global scale, evaporation influences climate. Large bodies of water like oceans and lakes release huge amounts of vapor into the atmosphere. This vapor helps regulate temperature and weather patterns across the planet. Changes in evaporation rates can even impact climate change. Sum up, evaporation is a simple yet powerful process that affects our daily lives, the environment, and even the global climate. From drying clothes to forming clouds, it's a key player in the water cycle and many natural and human-made processes. By understanding how evaporation works, we can better appreciate the invisible forces shaping our world.